There are few objects more useful and widespread than the paperclip. The paperclip is a useful tool patented in 1899 by Johan Weiler, a Norwegian man who designed it to hold various pieces of paper together without ripping or marking them. Being such a simple object, the paperclip has a virtually endless life cycle, but its small size and low cost allow users to take them for granted and keep poor track of them for later use. As a result, tens of billions of paperclips are purchased worldwide, 20 billion of them in the United States alone. The most common type of paperclip, the gem paperclip, which is made of nickel-coated steel, is sold in boxes of 100 for as little as 16 cents USD. Although paperclips seem like a harmless little piece of wire, its life cycle analysis proves how much energy is required for their production, packaging and transportation. The starting point of a paperclip is the extraction of the mineral hematite, which is to be smelted to obtain iron, main ingredient of steel. The smelting process involves putting the mineral in a furnace at very high temperatures, often higher than 1000 degrees Celsius. The furnace is fed with coal, which is a highly pollutant source of energy. The extended process of producing steel involves sudden changes in temperature, which requires water, or in some cases oil. Besides high amounts of energy, oil and water, specific minerals are added to the molten metal to achieve the desired qualities of the finished product, paperclips in this case, since the goal of a paperclip is to be elastic yet resistant to fatigue and corrosion. The right minerals have to be extracted, transported and added to the smelting process. Vanadium is added to increase the hardness while reducing the effects of metal fatigue, and large amounts of chromium and nickel, often 18 and 8% respectively, to inhibit corrosion. On the other hand, sulfur, nitrogen, and phosphorus make steel brittle, so these elements are removed from the hematite ore during processing. Worldwide, 1.035 million tons of steel were produced in 2004, out of which 272 million tons were produced in China alone. As seen previously, steel requires large amounts of iron and other minerals that have to be mined in order to extract the required elements for each type of steel. Extracting these minerals has both environmental and social repercussions that have to be taken into account when analyzing the manufacture process of paperclips. There are various mining practices. Amongst them, open-pit mining is the worst. In this type of mining, the outermost layer of the earth is absolutely removed and sorted in a factory for the desired ore. All vegetation is stripped away, killing animals and plants, and polluting the water and air. In some cases, entire communities are displaced in order for these excavations to occur, having a deep impact on society. When the ore is extracted and taken into the smelting facility, fumes are expelled into the air, worsening the environmental and social impact of steel production. Often, the mining site and the smelting facilities are far apart, so the transportation of unstable minerals along great distances is added to the negative effect of mining. When the desired type of steel is reached, the ingots are pressed in a machine and a thick steel bar is extruded. Various passes through the press are needed for this thick steel bar to achieve the 1-2 mm thickness used for the production of paperclips. The steel wire is transported from China to the United States, where the paper clips are manufactured and packaged, creating tons of emissions in transportation. Finally, once the steel is in a wire form, it is nickel-coated and finally cut and bent into paper clips. The paper clips travel through the assembly line to be packaged into cardboard boxes of different capacities, the most common being that of 100 clips per box. At this stage, the paper clip has met its partner, the cardboard box.